Okay, so in this course we're going to create a survival game. So we have a little character here in the middle. She's wielding quite a big pickaxe, and she can move around the map with the WASD keys, and she can use the mouse to click and mine resources. So that was a rock, and that dropped a few little pieces of rock for us to use to craft things. We can go up to a tree and whack the tree, and we managed to get some rock and some logs. So we mined and both the tree and the rock simultaneously. That's kind of cool. So we can wander around, and we can also forage in these bushes, and that will drop some berries. And so we also have some monsters here. So we've got a bear over in the top left corner. So if we get too close to this bear, that will aggro the bear. Aggro the bear, and the bear will come running after us. And we're faster than the bear, but eventually he will get us. And when he gets us, he starts hurting us, and but we can whack him and keep whacking him and backing off, and he will eventually die and drop some fur and some meat. We have a ent down in the bottom left, which we can also kill. And he drops, for some reason, a violin and a crossbow. And in the bottom right there's a dog, and what I'll do is I'll just let the dog kill us. So the dog is just damaging us there, and then we die. Very sad. So there's quite a lot to this first part of the course. There's quite a lot to do. You'll learn how to create this tile map using a program called Tiled, which will export some files that you can use in Phaser to draw this great map. And also in Tiled you can designate spawn points, so you can specify where these monsters are going to appear on the map, which is super cool. You can actually also add data onto those spawn points, so you can say what those monsters are and what they're going to drop. So we'll go through all that. We're going to be using modern JavaScript, so that means classes, ES6 stuff like array methods, array functions, all that good stuff. So we're going to be using modern practices like that, so you'll be learning some good JavaScript. And then you'll get a pretty cool game at the end of it. This is part one, and of course there's a lot to do to get to this point, but you'll be surprised how quickly you can knock up something like this, and then of course you can take this in any direction. It's a good basis for a game. You can take this in all sorts of directions, but there will be a part two where I will take it in my particular direction, and that means we'll add an inventory system, a crafting system, and things like that. So let's get on with part one of the course. So for this course you're going to need Visual Studio Code. So if you go to code.visualstudio.com, and if you click on the download for your OS, so I'm on Windows, so I would click download for Windows. And once you've installed that, if you open Visual Studio Code, you're going to need to install the live server extension. So if you come down to extensions and click here, and then type in live server, and then you want to come along here and click install live server, which enables you to right click on a HTML page that you're editing in Visual Studio Code and open it with a HTML server. The other piece of software that you will need is Tiled. So go to mapeditor.org, and then if you click on download at itch.io, and then if you download it here and install the tiled map editor. So let's get started. The first thing we want to do is open a terminal. So click on Terminal, New Terminal. And we want to make a directory or a folder to put our survival game in. So I am going to put mine in a folder on my D drive called Web. And then if you make directory, and I am going to call mine survival game. And then if we change directory into that folder we just created, and we open it with code full stop and then -r so that it will open in this window. And so we have our blank folder open. So the first thing we want to do is create a new file, and we want to call it index.html. So this will be our web page that holds our game. And using Emmet, we can just type HTML and choose :5, and that will scaffold out a basic HTML5 page for us. And we want to change our title to survival game, and we want to bring in Phaser, and we're going to be using the Matter physics engine, which is a pretty powerful physics engine, adds a lot of capabilities to Phaser, perfect for our use in this game. So first of all, let's bring in Phaser. So if I just paste in the CDN that I'm using, so I'm using this CDN here, with this specific version, I just found this version was a good stable version. Then we want to paste in a plugin for the Matter physics engine, which just helps a little bit with our collisions. Again, I'm using a CDN here to get up and running quickly. Now we want to create a div now, which is going to house our game. Give it an ID of survival game. We keep that blank because Phaser will use that to insert the canvas. And then we will specify our sort of script that we're going to start our game off in. So I'm going to keep all my scripts in a JS folder, and I'm going to call this survivalgame.js. So let's save that, and then let's create that folder. So create folder JS, and then under JS I want to create that file survival game.js. Now Phaser needs some config, so I'm going to create a config object where we can specify things like width, height, background color, which we're just going to make a gray so we can see it initially, type, and we set this to auto so Phaser can choose the best canvas to use, WebGL, etc. And then we will specify our parent, and that's the ID of that div. So we called it survival game. We're going to specify some scenes, but we'll keep this blank for the moment just to get up and running. Now I also want to scale up to get a kind of pixelated view. So we'll scale up by 2. And like I mentioned earlier, we are going to use the Matter physics engine, which is a bit more capable than the default physics engine. So we'll specify the default as being Matter, and then we will do some configuration for Matter. We actually want to turn debugging on so we can see colliders, and we want to turn gravity off because it's not a platformer, it's a top-down game, and that should be enough for physics. We now want to specify the plugins that we're using. We're just using that one Matter collision plugin. So we do that by specifying plugin, Phaser, Matter collision plugin. Nice simple name there. And that takes a key, Matter collision, oops, and mapping, Matter collision. And now we can create our Phaser instance and send it that config. So that should do for getting our Phaser game started. And actually, if we go back to index now, right click and do open with live server, we should see a nice big grey canvas here. And if we right click and do inspect element, we can see that sure enough we have a canvas element in here, 512 by 512. Okay, so the next thing we want to do is create our main scene. So if we create a main scene file in the JS folder, call it main scene.js. So this is going to be a class which we will call main scene, and it extends the Phaser scene class. So to get this working, we always should have a constructor for our classes, and we need to call super and send it a main scene string like so. Now the Phaser scene class has some methods that it calls. One of these is preload. So let's just check that this does get called correctly. So we will just console log out preload. We also have a create method that Phaser calls for us, and we will console log that out as well. And as you can imagine, preload is where we load all our images, and create is where we create our things like game objects. And then we also have an update method that gets called over and over again, 60 frames per second, hopefully, and we will just log that out as well. Now that's not going to work until we specify in survivalgame.js that we are using the main scene. So we want to type in main scene here, and if I just choose this top line here, it will import main scene We actually just need to stick a JS on the end there for that to be happy. And let's check that out. So that's good. We've still got our big grey canvas, and if we inspect element, and then if you click on the console tab down here, you see that preload's getting called, create's getting called, and update, you can see this ticking up here. So this is getting called 60 frames per second. So now we want to go back to main scene, and it would be good to just get a very basic Matter Sprite moving around. That's our player. So let's do that now. We need to create a Matter Sprite. Phaser.physics.matter.sprite, and we need to send this matter.world. And actually, if we save that and go back to index.html, we actually see this in the top left corner now. So this is our Matter Sprite. We can't move it around or anything yet, so let's do that. So to move it around, we're going to have to take some input from the player. So let's sort that out. So this .input keys, and we're going to use Phaser to handle our input. No, that's just this .input.keyboard.add keys, and we want to specify the keys that we're going to use for movement. So for up movement, we're going to use Phaser.input.keycodes.w. Down, let's just copy that, and down is going to be S, left is going to be A, and right is going to be D. So the WASD keys, standard movement keys. Okay, so let's deal with our movement now. So I'm just going to specify a speed in here of 2.5, and let's create a velocity vector for our player. So Phaser has vectors, which is super handy. So we will use Phaser's vectors. We just need a two-dimensional vector, and let's deal with our input here. So we just say if the input keys dot left is down, then we want our player velocity dot x to be equal to -1, i.e. going left. Else, if this dot input keys dot right is down, then we want our player velocity dot x to be 1, i.e. going to the right. If I copy that block to handle up and down, so up, we want our y to be -1, and down. We want our y to be 1. So we want to scale that vector using speed. That's just essentially multiplying our unit vector by the speed. And then we want to actually move the player. So we can use set velocity and use our x and y of our vector. So if we save that now and move around with the WASD keys, you can see that works. So right, left, up, down. There's only one slight problem with this, in that if we're going right and then down simultaneously, we're actually going super fast on the diagonal, and that's just because right by an x of 1 and down by a y of 1, and so diagonally we'd actually be going about 1.4, because it's the square root of 2 using Pythagoras. So we just want to make sure that on the diagonal we're also restricting that player velocity to 1, and there's a super easy way of doing that, which is something called normalize. And all normalize does is make sure that the magnitude of the vector is always 1, and it just fixes that diagonal speed problem. So we just normalize our player velocity vector before we scale it, and then if we go back and now do right and then diagonal, and you can see that it's always going the same speed now. So that is nicely fixed. Okay, so we have our Matter Sprite moving around. The only reason we can see it is because we've got debug turned on. So we haven't actually put a sprite image in there, and we can fix that now. Okay, we need to resource some sprites for our game. A good place to find sprites is on itch.io. So I found this great resource here, superdark.itch.io. His 16 by 16 free NPC pack is fantastic, and we can use it for free for commercial projects, which is super nice of him. Now if you scroll down, you actually want to download the individual frames. So if you click on download and save file, and if we open up the RAR file, right click and unzip, and I quite liked this character here, the townsfolk female character. So if you go in here, you can see we've got some idle frames and we've got some walking frames for her, which is great. So another resource is by gammafp.com /tools, and he's got a great Atlas Packer and Animator tool. So we are going to use this Atlas Packer, and definitely consider supporting him on Patreon if you start using this. And we can drop our images in here. So if we go back to our townsfolk female folder, and if we just drag and drop these in here, so we're going to drag our four idle frames, and we're gonna drag in our four walking frames. Like so. Now I find that a separation of 1 pixel is enough to get rid of some artifacts that you might see. So that works quite nicely, and then we can just simply click on export. And we want to give this a name, so I'm just going to call this female and then click OK. So if you go back to your downloads folder, you should see a female.zip file here. So if we extract that, and these are the two files we need to drop into our project, these two here. So if we go back to our project, and it would be good to have a folder for all our assets. So if in the root we create a folder called assets, and inside here create another folder called images, and let's drag and drop our PNG and JSON into this images folder like so. And you use the preload method to load your images. So we are just going to do this .load.atlas, and we're going to specify key of female, and we're pulling this from the assets images folder, and that was a female.png, and we need to specify the atlas JSON as well. So that was female underscore atlas dot JSON. So that's loaded our atlas in. So let's use this. So we'll send some extra parameters to the Matter Sprite constructor. So we will send an x and a y of 0 for the moment, and we will specify the key that we specified up here for the atlas, which is female, and we can say that we want to show the towns folk underscore f underscore idle underscore 1 frame. So you may be asking where I got that from. If we click on female underscore atlas JSON, you can see this is the name of this particular frame here, which is the very first frame of this PNG. It's that one there. Now that's not quite enough to get the sprite to show. We actually have to add it to the scene. So we do this dot add dot existing, and we specify the sprite we've just created on the line above. So we've added this Matter Sprite to the scene like so. So if we now go back to our index.html, right click, open with live server, we've got an error here. Well, definitely this .preload.atlas isn't a function, so let's go and see what happened there. That should just be this .load.atlas. Let's go back now. And we're seeing that it's trying to draw the sprite, but it's not quite succeeding. So let's see if the console gives us any clues. So it's saying this frame is missing, townsfolk underscore f underscore idle underscore 1. So let's see what's happened there. So the first thing to check is, are we loading the atlas correctly? And we are not. I completely failed to name that correctly. So that should fix that. And as you can see now, it is a lot happier. So we are now moving a visible sprite from an atlas around our canvas. So let's go one step further and actually animate our sprite now. So we can go back to Gamma's tools and open the Animator tool. And if we click on Import Atlas Image, we want to go to our Images folder and open female.png. And also have to open the female atlas.json as well. And so you should see these pop up in here. And we want to create two animations. You want to create an idle animation and then a walk animation. And let's do the idle first. So we click on idle and we just click in turn idle 1, 2, 3, 4, and you see them appear down here, and you can click play to preview. If I hold down Control, I can use the scroll wheel to zoom in here, and we can see that she's idling in place here. Let's do the walk animation now. So click on walk, and then again click walk 1, walk 2, walk 3, walk 4. And you can see that she's now doing her walk animation. So you want to save those animations, so click on this Save Animation button. Click Save. We can minimize that now, we've done with that. If we go to our Downloads folder, we should see this female_anim.zip. So let's unzip that. And that's just a single JSON file that we can drag and drop into our images folder. So now we can load up that animation in our preload. So we do this dot load dot animation, and we'll give this a key of female_anim. And we're loading this from assets /images /female_anim.json. Now we can simply go into our update method. We can actually remove this line, we don't need this anymore. And we can do this dot player dot anims dot play, and we can specify our walk animation. We'll say that we want it to loop, so we set that to true. Now I don't think I actually called it female_walk, so let's fix that now. If we go into our anim.json, we can change the key here, and we can say we want that to be female_walk and female_idle, and Control S to save. And that should play the female walk animation. So let's check that that's working. As you can see, we are playing the walk animation, and if we go back now and change that to idle. Control S to save, switch back, and we have our sort of bouncing in place idle animation. Okay, we have our player character moving around, but it would be good to do a little bit of a refactor at this point so that we can have a player class that looks after a lot of this stuff. So let's do that now. So if we right click on our JS folder and do new file and call this player.js, and this will be a class called player, and this will extend the phaser.physics.matter.sprite class. And so as per usual we should have a constructor. I'm going to send it a data object, and in our constructor we should call super, and we need to send the Matter Sprite constructor the matter.world and an X and a Y, a texture and a frame. So we're going to have to pass these all in. So let's deal with that now. So we're going to pass in a scene, an X and a Y, a texture and a frame, and we're going to pull those out of our data object like so. And then we need to add our Matter Sprite to our scene. So if we go back to main scene now, so we've done this bit here, and this is going to be replaced with player, and that should have done an auto import, but we just want to put a .js on the end there. Now we don't want to send it this .matter.world, we just want to send it the scene, and it's actually all inside one big object. So let's do that. So we've got a scene property which we want to set to this. This is the X, this is the Y, this is our texture, and this is our frame. And then we actually want to have our input keys inside our player, because that's what we're controlling. So we can do that. Now this, all this stuff, we actually want to pull this out and put it inside the player. But this is not this .player anymore because we're inside the player, so it's just this. Get rid of that as well. The rest of that is probably okay. But we need to go back to main scene, and inside the main scene's update method we need to call this .player.update, like so. Now the last thing I want to do is I want to move, because this atlas and animation is all to do with the player, I actually want to move this inside the player class as well. But the trouble is we're creating the player here, and so at this point we don't have access to a player instance. But that's not really a problem, because this would be better to be stuck inside a static method on the player. So let's do that. So we create a static method with the static keyword, so we just say static, and then we can call it anything, but I'm going to call it preload. And we need to send it the scene, and we can copy over. So if we switch back to main scene and we just copy these two, let's just delete that, copy these two lines and go back to player and paste those in there. But instead of this, we want to use the scene that we're passing in. And if we go back to main scene, instead of doing all that now, all we simply need to do is call the preload method and send it the scene, which is, we're inside the scene here, so that's this. So static methods are methods actually on the class itself, so it's not on the instance of a class, it's on the class. And so we don't have to have instantiated the instance at this point, because this method is just a class method. So that's pretty handy in this case. Now then, let's see if that is all happy. So if we right click our HTML file and do open rely server, and as you can see, we're still happy, we're still being able to move around our player, and our animation's still working. But now we've encapsulated all that complexity inside player where it belongs, and main scene now is looking a lot cleaner and tidier. So we have our player moving around, but unfortunately at the moment they only show this idle animation, and we want to switch between an idle animation and a walking animation depending on whether they're moving or not. So let's fix that now. So what we want to do is you want to check for the absolute, i.e. positive value of our velocity in either the X or the Y direction. And if either of them are greater than a sort of small value, then we're going to presume that the person is moving. So we don't actually need that bracket there. And let's take this and we're going to paste it down here, put in an else. So if the x component of the velocity is greater than 0.1 or the y component of the velocity is greater than 0.1, we're going to presume we're moving, so we want to play the walk animation. So this velocity property here doesn't actually exist. It actually exists on the body of a Matter Sprite, but let's make that a little bit easier to get at. So if we set a getter for our velocity and we return this dot body dot velocity, and that will give us this velocity property here. So let's check and see if that works. So we're idle, and now we're showing the walk animation. It's a little bit hard to see, so let's actually lighten our background. If we go to survival game, and let's lighten this to 999999. Now that's a little bit easier to see. We're switching between idle and walking. So as you probably noticed, we have this green square around our character, and that's actually a collider, and we actually want to have a circular collider around our character, and then a little bit further out we want a circular sensor, and we're going to use that to detect whether we're near a rock or a tree, and that means that we'll be able to harvest that rock, tree, etc. So let's do that now. So if we go back to our player class, and we need to pull out the body and the bodies from phaser.physics.matter, believe it or not. And this will enable us to create our own colliders. So we can create a player collider here using bodies.circle, and we want to place the circle at this .x, this .y. We'll give it a radius of 12, and we're going to say is sensor. I'm going to say this is false because it's a collider, and we're going to give it a label of player collider. And we're also going to create a player sensor, and very similarly we're going to use bodies.circle, again this .x, this .y, but it's going to be larger, have a radius of 24, and this is, funnily enough, a sensor, i.e. it's not a collider, and we're going to call it player sensor. Now what we can do now is create a compound body that consists of our player collider and our player sensor. And we're going to give it some friction of 0.35. And then we need to set existing body equal to this compound body. and we're just missing a comma here, so let's fix that. Let's go back here, and as you can see, we now have a circular collider and a circular sensor. Now we can test this collider out very simply by going back to our main scene, and we can just copy this line, but let's call it it's just a test player, and let's put it a little bit further into the screen. So 100, 100, let's save that, go back, and now this is our test player, and we can walk around and bump into our test player like so. But as you can see, we are now sort of at a tilted angle here. We're kind of keeling over, so we can fix that very easily by going back to player and doing this .set fixed rotation. And if we swap back now, we should see that we've got a fixed rotation, so we're not going to keel over, and we can interact with things now, which is great. So the only other problem here is you can see that we're not in the middle of our collider. So the easiest way of fixing that is if we come back into Visual Studio Code and open up our atlas, we need to adjust our anchors. So the X anchor is fine, we're in the middle, that's good, but the Y anchor we need to amend. So if you just select this line here, because we want to amend them all, as you can see they're all 0.5 at the moment, and if you do Control H and we want to replace 0.5 by 0.8, and then if you click replace all, see those all changed. Click save. Now if we go back and refresh, we can see that our main character is now in the middle of our circle. This one hasn't changed because we're not actually playing an animation on there, so that's still going to be wrong, but this one is the one we care about, and that is correct. Okay, so let's work on our map now. So there's a really nice RPG nature tile set. So if you go to stealthix.itch.io/RPG nature tile set, and we can download this here, and yeah, definitely throw him some money if you would like. We can download the tile set here, click save. So now we want to copy this RPG nature tile set PNG into our images folder, like so. And then we want to use this tile set to create our map. So we now want to go into tiled, and we want to click new map, and we want an orthogonal map with a base 64 uncompressed tile layer format. We want our map size to be 16 tiles by 16 tiles, and the tile size we're using in our tile set is 32 pixels. And we want to save this in our assets images folder, and we can call it map.json. And now we want to load our tile set, so if we click new tile set, and if we make sure embed in map is ticked, so tick this, and if we click browse and then find the RPG nature tile set PNG and click open. Make sure these are all set like so, and then click OK. So now we can use this tile set to draw out our map. So we can put our corner tiles here, so you just click here and then click there to place those. And then you can actually drag to draw like so. Click on this one, drag and draw. And then we can fill. Let's click this middle one, and there you go. We've created a very basic map. So let's keep it like this for the moment and check that it works. So if we click on File and Save, that will save our map.json. And now we need to bring this into Phaser. So the first thing we want to do in Phaser is in our main scene class, inside the preload method, we want to do this .load .image, and we're going to call this tiles. And this is our RPG nature tile set .png. Then we want to load the JSON definition of our map using tile map tiled JSON. I'm going to call this map. And that's assets, images, map.json. So that's not quite enough to get us going. We need to then do some work in our create method. Let's delete this line and let's delete this as well. And we do const map is equal to this dot make dot tile map, and we specify the name of our map, our key, which is map, relates to this one here. And now we want to add our tile set to this map. So we do map.add tile set image, and we'll just call this RPG nature tile set. And we're using this image that we loaded up here, and this is 32 . So these are 32 by 32 pixel tiles. And now we want to actually draw our layers. So we do that by calling create static layer on the map. So create static layer, and we need to specify the name of our layer, which is tile layer 1. This is the same as it is defined in tiled. So if we go back to tiled, this is tile layer 1, and we're using the tile set that we created here, like so. So now if we open our index.html, and we probably have an error, so let's see what's going on here. Again, I've said preload instead of just load. Let's fix that. There and there. And click save. And there we have our lovely map. And we can walk around on it like so. So the map's a little bit square and boring, so let's just do the bare minimum to fix that. So let's select water tile, and we'll select this stamp tool so we can draw some water up here. Maybe add some water on the corner there. Add a little bit of water here, and these look a bit ugly now, so let's fix that so we can just draw these in like so. Of course, make this map your own, make it any shape you want. Just keep in mind pretty simple. Okay, so we pretty well finished with that layer, so we can actually stop ourselves from editing it by clicking this lock here. And let's create another layer, and let's draw just a little bit of variety on this to get rid of this, the blandness of all this green. So that will do for our second layer. So if we save that now and switch back to our code, and we can simply copy this line here. This is layer 2. Change that to 2 as well. Switch back, we can see that our map is shown quite nicely like so. Okay, so we have our map that we can walk around on, but there is one glaring problem in that our character can actually walk on water. So let's do our JC fix now. So if we go back to tiled, and if we open up our tile set properties, so click on edit tile set down here, and we want to select all the tiles that we want to add collisions to. So we want to add colliders to this one here, and then if you hold down Control you can select a few of them. So we want to select all of these edge tiles here, and also these ones over here. So hold down Control and click all these. And then we want to add a custom property. So if we click on this plus button down here, add property, and we're going to add a property called collides. and then make sure that you choose bool in the drop down box here, and then click OK. And then what we want to do is, for all of these, we want to make sure that collides is set to true. So we click this tick box here, and then if we Control S to save, then we need to add some code to turn on the colliders, because we would see them in here if they were turned on, and they're not at the moment. So let's add that code now. So you want to add the code after this const layer 2 line. So we do layer 1 dot set collision by property, and the property we added was collides, and when that's true we're going to enable collisions, and then we need to tell the Matter physics engine that we're adding colliders. Like so. So if you save that now and go back to survival game, you can see that we have colliders all around our edges, but our character is stuck in the corner here off the map because they start at 0, 0. So let's fix that now. Let's put our character a little bit into the map, save, and now we are inside all these colliders. But of course the trouble is these colliders are on the tiles themselves, so they're rather large. So let's fix that next. So in tiled we can specify the size of the colliders. So let's do this top middle one to start with. So if you hold down the control key and scroll in, we can zoom in here, and if you click on this insert rectangle, we can insert a collider like that. And we want to specify a width of 32 for this collider and a height of 8, and we want to put it at an x of 0 and a y of 0. And if we Control S to save and go back to our game, you can see now that our colliders are a much better size. So let's do that with all the tiles that we are using around the edge. So this corner tile is going to need 2 colliders, one here and one here. So we can click and then click to add 2, and then if we click on this top left icon here, select objects, we can select them and specify their size individually. So let's do that now. So as you can see, for this particular collider, our y needs to be 24, but the x is still 0. So for these particular tiles, we just want to put an 8x8 collider in the corners here. And now we have our colliders set correctly for our whole map. So our character can walk around the island but can't fall into the water.